Let's now look at quadratic graphs, and here's f of x equals 6x squared minus x minus 12. It's quadratic because it's got a degree of 2, so it's an x squared graph. So I mentioned before in linear graphs that the key points here we want to find are the x-intercepts, and to find those we make y equals 0. And to find the y-intercept we make x equals 0. There we go. Alrighty, so, and in these ones, just at the moment, we're not going to find turning point. Okay, down the track a bit when we do calculus we will, but just for the moment I want to get us practicing just drawing graphs, finding x and y-intercepts. So we're going to make y equals 0. Now, for all intents and purposes, y equals 0 means f of x. Same thing, okay, so we're going to make f of x equals 0, equals 6x squared minus x minus 12. And in the last video we talked about factorising these guys, okay, so hopefully you were able to do that. So let's, we might just go to the next slide just for a moment to factorise this. So 6x squared minus x minus 12. Okay, so our grids can either have 3x and 2x, or our grids could have 6x and x. So we're going to find factors here of negative 12. So if I put negative 4, actually, I won't do that. If I put negative 4 here, and I put, let's say, 3 there. Now, why have I done that? Because I need factors of negative 12. One has to be negative, the other positive. On the other side, I've got factors of 6x squared. Now, it could be 6x and x. I've chosen here to use 3x and 2x, but we must realise that that could be 6x and x. Anyway, so we've got 9x that way, and we've got negative 8x that way. Total of x. Now, we've got negative x. So while you can fix that, if we've got the wrong sign, we can fix that by putting a positive 4 there and a negative 3 there. That gives me negative 9x that way and positive 8x that way. Total of negative x. And that's what we've got as our middle term. So there are our brackets, 3x plus 4, 2x minus 3. Back to the previous slide. 3x plus 4, 2x minus 3. Now, I'll put the equal 0 on this side now. Two solutions there are x equals negative 4 on 3, opposite sign over coefficient, and 3 on 2. Hence my x-intercepts are going to be negative 4 on 3, okay, and comma 0. And the other one is going to be 3 on 2, comma 0. Y-intercept, we're going to make x equals 0. So basically y is going to equal f of x 6 times 0 squared minus 0 take 12. Now, after a while you'll soon realise that, as soon as you're putting x into this original equation, you're really only going to be left with x equals 0 into that original equation there. You're really only going to be left with that number out by itself. So the y-intercept is going to be 0, negative 12. So there we go. We've got our x-intercepts and our y-intercept. If we copy that over to the next free slide here. There they are. Okay. And we're ready to draw our graph. Okay, so with our graph, we've got our x-intercepts at negative 4 on 3 and also 3 on 2. So we're not finding turning point just at the moment, and our y-intercept there is 0, negative 12. It's a bit out of scale, I know, but you get the idea there. So that's how to draw a quadratic graph. So you might like to pause the video here and have a go at 1e, numbers a, b, and C. Okay, second way we can draw quadratics is by having our equation in turning point form. And you've probably seen this before. Y equals a outside of x minus b squared plus c. Okay, so an example of that might be y equals negative 2 outside of x plus 3 squared minus 4. In fact, we're going to look at this one here because rather than verbally, because it's a demonstration video, rather than verbally trying to explain the significance of that, which I know you've seen before, I'm going to do it in the context of an actual example. Okay, so let's look at y equals negative 2 outside of x plus 3 squared minus 4. First important thing to look at is the a term here, which is the term out the front. If that term is positive, okay, our graph will be that shape. If that term is negative, the graph will be that shape. And in this case, I know straight away by seeing that negative 2 out the front there of our bracketed term, that is going to be that inverted shape there. Let's have a look at the plus 3 there. Okay, what that's going to do is going to take the basic shape, okay, of the quadratic, and the basic shape, remember, is either this one here, smiley face one, or the sad face one if you like, and move it. What we're going to do is move that in certain directions. I'll get back to the significance of the 2 in a moment. But the plus 3 means that the parabola will be shifted to the left 3 places. Now, you've almost got to reverse your thinking here, because you might think, well, plus 3, wouldn't that take it 3 positive places to the right? No. A plus 3 there takes it to the left 3 places. A negative 3 would take it to the right. Then we've got the negative 4 there. That's going to take the graph, the basic shape, down 4 places. Okay, so a negative will take it down, a positive will take it up. Now what about the 2? Well, a big part of chapter 2 will be talking about dilations of graphs. Okay, I'm going to leave that to chapter 2. Okay, but basically that will alter, in fact it will make narrower, if you like, if I can use that term, the shape of the graph. But we'll just leave that for the moment till we get to chapter 2. Let's do the basic things for the moment. Alright, so let's take that equation and we'll just put it onto the next page. Okay, and we'll now make an attempt to graph this, just get rid of that, by setting up some axes. Okay, so in the previous slide I talked about the various movements of the graph, and let's just say at the moment I'm just ignoring the 2 because that's dilations and that's going to be covered more in chapter 2. So just look at the basic shape of the graph. So notice first of all here in this first graph here, on the left hand side, bottom left, I've inverted our parabola because there's a negative 2 out the front there. Okay, so I've taken it from its usual smiley face shape and inverted it because of the negative. I've then taken it and moved it 3 places to the left. Why? Because that's a positive 3 inside the bracket. Last step is it's gone 4 places down to negative 4. So the turning point for this graph, that's why it's called turning point form, is negative 3, negative 4. So that's the turning point there for that graph. So how do I know that? Because I look at this equation, I'm circling in blue, and I know that the positive 3 takes it to the left, so negative 3, the negative 4 takes it down to negative 4. So they're the movements of the graph. Inverted, 3 to the left, 4 down. Where's the turning point after those movements? It's at negative 3, negative 4. Let's look at the last answer there and look at the domain and range of this graph. Remembering in the linear graphs video we talked about domain being the x values covered by the graph, and remembering here that this graph, okay, if you like I put little arrow ends on there, it goes on forever. So it's going to cover all x values in both directions. It's not limited in any way. I haven't put any constrictions there on the x values of the graph. So we can say there that its domain, okay, is the real numbers. Okay, so if I just write it down, the real numbers. We can also say the domain is from negative infinity to infinity. Now why have I got curly brackets there and not square brackets? Remember, curly brackets means that you don't include the values. Curved brackets means you don't include the values, square brackets means you do. Now, infinity is not defined as such. So whenever we're dealing with infinity, we do not have I draw one there, we do not have the square brackets, we always have the curved brackets. Okay, so when we're doing our domain there, the domain is R, or it can be defined as negative infinity to infinity. The range here, if we look at and I might change pen colour here for a moment. If we look at the y values it covers, this graph covers all the y values, okay, below, if I look there, that's -4, below -4. Now if I look at any other y values, I can choose any of them up here, okay, I'm not hitting the graph at any stage. Okay, the function is not defined at those y values. Okay, so I'm only hitting the graph here for y values less than -4. So the range of this graph is y is less than and equal to, trouble with the pen here, -4. Or we could also say start again, breaking my own rules there. All the values from negative infinity, okay, way down there, curly bracket, remember, okay, comma, up to -4, and we're including -4, so we put a square bracket there. I'll just write that negative infinity a bit neater because it's not quite clear enough there. Let me just do that again. So negative infinity, okay, comma, -4, curved bracket, negative infinity, square bracket at -4. So they're the y values it covers. So range, it's going to cover all the x values. That graph goes on forever, left and right. For y values, it only covers y values less than -4. Next skill I want to show you is given a quadratic graph, finding the actual equation. Alright, and we're going to use the turning point form again. So notice that the usual quadratic equation, if I just draw it in a different colour, perhaps in a purple colour. Okay, so our usual quadratic equation, our standard graph of y equals x squared. So our standard graph is like that. Okay, that's our standard graph. I probably haven't drawn that very symmetrically, but you know what I mean. Where has that graph been taken? That's the question. For the graph in black here, where has it been taken? Well, it's been taken, okay, because it's turning at that point there, -1, -6. It's been taken 1 unit to the left, and it's been taken 6 units down. Alright, so remember our standard form, y equals a outside of x minus b squared plus c. If we've got 1 unit left, and this is where we're going to think in reverse, that means we've got x plus 1, okay, inside our bracket. If it's been taken 6 units down, that's going to be -6. So the plus 1 in the bracket takes it to the left one, a -6 outside the brackets take it down 6 places. So that's a general form. Okay, so we've established then, okay, that the graph is of this form, y equals a outside of x plus 1 squared minus 6. What we don't know is a. Okay, how are we going to find a? Well, notice that if I just go back a sec, we had 2 points on that graph. We had a terminating point here. Oops, didn't mean to write that out. We had a terminating point here at -5, 10. Okay, so we've got that point, and we've got -6. In fact, sorry, that should be, yeah, that's right, -5, 10 and -1, -6. So let's write those 2 points down. -5, 10 and -1, -6. Those 2 points are on this graph, right? They form part of this line. we can use one of those points now to find our A, because once we find A, we'll find the equation. So what I'm going to use is this guy here. I'm putting the asterisk next to it now. I'm going to use -5 and 10. So that's X, and that's Y. So where I've got Y, I'm going to put 10. And where I've got X, I'm going to put -5. And it's a strategy you can use all year for finding graphs. If you don't know some information, you can substitute in a point to find that information. So 10 equals A. -5 plus 1 is -4 squared minus 6. 10 equals -4 squared is 16A minus 6. Take the minus 6, -6 to the other side, we get 16 equals 16A. A obviously therefore equals 1. So, if we're looking at that, our value of A equals 1. The graph is therefore 1. Y equals, we don't put the 1 in, X plus 1 squared minus 6. Okay, last graph I want to do on this video is the graph of Y equals a half outside of X minus 1 squared plus 2. I want us in the answer to put down the turning point, the intercepts, and we're also going to talk about the range of the graph as well. Alright, okay, so let's start with the turning point. Okay, now the half outside the brackets there, that will be a dilation factor. As you'll see later on, that will make the graph a bit of a wider shape, more in chapter 2. That minus 1, X minus 1 inside the bracket, that will move the graph to the right 1 unit. And that plus 2 there will move the graph up 2 units. So if we take the basic graph of Y equals X squared, if we move it to the right 1 and then up 2 units, okay, we're going to get a turning point of 1, 2. Okay, so that's the turning point. We've done that. Turning point is 1, 2. Next we're going to find the intercepts. Okay, and as we've said before, to find x-intercepts you make y equals 0, to find y-intercept you make x equals 0. Now you can save yourself some time here. Okay, not all these quadratics have x-intercepts. Right? If they do, well and good. But as we just said, if I look at this graph, the turning point now is, if I just draw a rough sketch, is 1, 2. Okay, so 1 across and 2 up. So that would be there. Now, I forgot to mention that because that's a positive 1/2, the graph is of that shape, like that. So I know my graph is going to be something like that. I don't need to bother finding x-intercepts because I know there are none. So once you know your turning point, draw a quick sketch, then you know whether it's worth trying to figure out x-intercepts or not. So there are none because the graph will not cross the y-axis. So I know I can just have to find the y-intercept, and to do that I make x equals 0. So y equals 1/2 times 0 minus 1 squared plus 2. Y equals 1/2 times -1 squared plus 2. -1 squared is 1. 1/2 times 1 is 1/2. So y equals 2.5. So the y-intercept is going to be 0, 2.5. Alright, so we're ready to draw the graph here. And we'll draw it up a bit more, a bit neater than what I've got at the moment. So, oops, sorry. So, let's copy that over to the next slide, that bit there. Okay, so I've got my turning point and my y-intercept. So, draw up some axes, like so. Turning point, there's 1, oops. There's 1 and 2. Turning point there. Y-intercept at 2.5. And parabola like so. Y-axis and x-axis. And there's our graph. The last thing we have to look at is the range of this graph. And changing pen colour once again to demonstrate this, we're looking at y values that this graph will cover. So we'll look at all the y values here. I'm not hitting the graph. First time I hit the graph is at y equals 2, and then I hit the graph, I hit the graph from then on above 2. So it's the y values the graph is covering. Okay, so the range, and just another way of putting it here, if you like, y is 2 to infinity. Remember, with infinity, it's always curved brackets. So from 2, including 2, up to infinity. Okay.